In this example, we're going to balance another half reaction, but this time it's in basic conditions. So we're going to follow the exact same steps as the last problem, except we'll have one final step where we're going to add hydroxide ions to convert this from acidic conditions to basic conditions. So I'm going to start by writing out what I know. I have iodine converting into periodate ion. I'm going to balance my iodine atoms by putting a 2 in front of the periodate ion. Next, I'm going to balance my oxygens, and I do that by adding 8 water molecules to the reactant side. Next, I want to balance my hydrogen atoms, and so I have 16 hydrogen atoms on my reactant side, which I just added from my 8 waters. So I'm going to balance that by adding 16 hydrogen ions to the product side. Next, I want to balance my charge. So my 2 periodate ions and my 16 hydrogen ions leaves me with a charge of plus 14. So in order to cancel that out, I'm going to add 14 electrons to the product side. Lastly, to convert this to basic conditions, I need to neutralize my hydrogen ions. I do that by adding 16 hydroxide ions to the products and the reactants. The 16 hydrogen ions and 16 hydroxide ions will neutralize each other to form 16 water molecules. And so rather than writing 8 water molecules on the reactants and 16 water molecules on the products, I'm going to cancel those out and just write 8 water molecules on the products. And so I'm left with 16 hydroxide ions plus iodine yields 2 periodate ions, 8 water molecules, and 14 electrons. This reaction represents an oxidation, and we can tell for 2 reasons. First of all, electrons are a product. Electrons are lost. Loss of electrons is oxidation. Secondly, if we look at the oxidation state on the iodine, we can see that it goes from its elemental form, which would have an oxygen state of 0, to the iodine, and the periodate ion has an oxidation state of plus 7. So that represents oxidation.